Hello everyone. In this video, we will be discussing one major topic in Module 1 non-traditional machining process. Of course, which is a very important topic. So that is why exclusively I will be discussing this topic in this video. That is selection of non-traditional machining processes. So based on some of the characteristics and some of the properties, we will be discussing this thing. And it's going to be very interesting. We will see. So, under selection of non-traditional machining process, we have four major, we can call it as a parameters, or we can call it as a considerations, or like whatever. So, what are all they? First one is physical parameters. Second one is shapes to be machined. Third one is process capability or machining parameters, and fourth one is economic consideration. Already in video 2, we had very detailed discussion on non-traditional machining processes, like different energies based on the nature of energy, like mechanical, electrical, chemical, and even thermal. So all those things we have discussed, but still and again the different processes also we have discussed. It may be ultrasonic machining process, or it can be a laser beam machining process, abrasive jet machining process, like electrochemical machining process like laser. Like there are many processes also, just generally we have discussed. But like for which material which process should be selected, or like for which material. That's what we are not clearly aware for which material which process is recommended and which combination is recommended. So all those things we have are not discussed in detail in the second video, and here we will be discussing in the detail about all those things, like for which process, like which for which material or which kind of like the output, which process is recommended. So all those things we'll be discussing now. So we will discuss one by one. First one is based on the physical parameters. So these are all the physical parameters of various unconventional or the non-conventional machining process, and you can able to see like the parameters I have just listed here. That is based on the potential V or the current A, or power in terms of kilowatts, or like gap in terms of mm, and what is the medium and what is the work material. For all the possible like non-traditional machining process, I have just listed here. That is starting from electrochemical machining, where the potential required is 5 to 30 volts, and the current required is 10,000 amps is required. And moving to the electrical discharge machining, and the potential required is 50 to 500 volts, and the current required is 15 to 500 amps. And electron beam machining, where the potential required is 200 into 10 power 3 volts is required, and current is very negligible amount of amps, that is 0.001 amps is sufficient. And moving to the laser beam machining, the potential required is 4.5 into 10 power 3 volts, and the current required is 2 amps. And the plasma arc machining, where the potential is 250 volts and current is 600 amps. And for ultrasonic machining, the potential is 220 volts and current is 12 amps. For abrasive jet machining, the potential is 220 volts and current is 1 amps. And moving to the power, for ECM, EDM, EBM, and LBM, PAM, USM, and AJM, you can able to see 100, 2.70, 0.15, 20, 220, 2.4, and 0.22 kilowatts respectively. And what should be the gap and what should be the medium required? All the gaps, the values is mentioned here is in terms of mm only. So for electrochemical machining, it is 0.5 mm, and the medium is electrolyte. For electrical discharge machining, it is 0.05 mm. See, practically, which is very difficult. In terms of in case of the traditional machining process, which is not possible at all. And the medium here is a dielectric fluid. And in case of the electron beam machining, you can able to see 100 mm gap should be maintained between the tool and the workpiece. And here the medium is the vacuum. Very important, and point to be noted only for the electron beam machining. And moving to the laser beam machining, the gap maintained should be 150 mm. The highest gap we should be always maintained between the tool and workpiece among all the processes, nothing but laser beam machining process. And here the medium is air. That means like a normal atmospheric condition which can be performed. And moving to the plasma arc machining, where the gap should be maintained is 7.5 mm, and the medium should be like argon or hydrogen or the nitrogen. and for ultrasonic machining process 0.25 mm is the recommended, and the medium should be usually abrasive grains and water. And for the abrasive jet machining, it is nitrogen or carbon dioxide or air. And moving to the work material, listen here. For electrochemical machining process, usually difficult to machine materials are recommended for the electrochemical machining process, which I mean talking about the conventional machining process drawbacks. And moving to the electrical discharge machining, where the tungsten carbides and electrically conductive materials, where it can be machined in the electrical discharge machining. And what materials can be recommended for the electron beam machining? Everything. It may be a ductile material, brittle material, everything is recommended for the electron beam machining. Similarly, for the laser beam machining, all the types of material, ductile, brittle, composite, everything is recommended. And moving to the plasma arc material, all the material which conduct electricity, where it is recommended, because some metals like stones, wood, composite, usually it is it doesn't conduct electricity. So based on that, and moving to the ultrasonic machining, where tungsten carbide and glass quartz, these are all the materials is recommended for the machining process in the ultrasonic machining process. And for the abrasive jet machining, hard and brittle materials, you can able to see only these two kind of materials recommend for the abrasive jet machining. This is all about the physical properties, or like we can call it as the physical parameters. And moving to the next one, shapes to be machined. Here you can able to see for producing micro holes, laser beam is recommended. For producing small holes, electron beam machining is recommended. And for deep holes, electrochemical machining is recommended. For shallow holes, ultrasonic machining and electrical discharge machining. For precision through cavities in workpieces, USM and EDM. And for honing, electrochemical machining. For etching small portion, ECM and EDM. For grinding, HIM and EDM. For deburring, ultrasonic machining and abrasive jet machining. For threading, EDM. For clean, rapid cuts and profiles, plasma arc machining. And for shallow pocketing, abrasive jet machining. And the material applications for of various machining methods you can able to see here. So all those things are aluminium, steel, superalloy, titanium, refractory material, also all those things. Anyway, like in detail, we will not be discussing all these things. When we discuss the concepts of all the non-traditional machining process, just for the general knowledge, all these basic informations are required. You can able to see continuation of ceramics, plastic, glasses. So which process is good or which process is poor or fair. So all those things we can able to see in this particular table. And moving to the third one, the machining characteristics or the process capabilities. So the various machining characteristics and the process capabilities that are the governing in non-traditional manufacturing techniques are metal removal rate, tolerance maintained, surface finish obtained, depth of surface damage, and power required for machining. These are the machining characteristics. We should keep all these five process capabilities, or like we can call it as the characteristics while doing the machining. And last one, economic consideration, which is very important among all those things, where the various processes we will be discussing, which will be analyzed based on the following factors, that is capital cost, tooling cost, consumed power cost, metal removal rate efficiency, and tool wear. You can able to see like L indicates low, VL indicates very low, and VH indicates very high, and M indicates medium. Just go through this particular table again. We are not discussing in detail because you cannot remember this while discussing each and every topic individually, where we can able to discuss about the capital cost, tooling cost, power consumption, metal removal rate efficiency, and the tool wear. All those things we can, for example, randomly if I want to check for the electrical discharge machining, where the capital investment is medium, where the tool cost is high, where the power consumption is low, where the metal removal rate efficiency is high, and the tool wear is high. So based on that, we will be discussing. So with this, I'll be winding up this video, and this is a very important thing, and you can just pass this part, particularly this fourth one and the third one, all those things. I mean the second one and the fourth one, you can just pass it, and you can just go through the for different material, what is the characteristics of it, may be a shape, or it may be a economic point of view. All those things you can just check it out, and we will be discussing in detail, particularly when we discuss the individual processes. Thank you.